So in our last couple of videos, we created and sort of explored this big drill box. But you might be wondering to yourself, why would we create this? Why would we have all of these different types of holes? What is the purpose of all of it? And so let's see if we can't explore that with a new document. And in this new document, I actually don't want you to create anything. I just want to insert some things. So let's go over here to Insert, and let's go to Exert McMaster-Carr Components. And then I want you to select just screws and bolts. Now, the first thing I want you to select is inch. Then let's scroll down to round head screws and select this. Then let's make sure we select Phillips. And then let's go over here to thread size and let's find 1/4-20. Here we are. And let's make sure that this has a length of 1 inch. And so basically, I'm going to make sure that if I select a screw right now, it's going to have all of these features. And I'm just going to select the first one. And I'm going to make sure I don't have SolidWorks selected. I want to make sure I have 3D Step selected and then hit download. And this inserts this screw into my file. I'm going to hit OK. Let's do that a couple more times. Let's go to Insert, McMaster Parts. Same thing, screws and bolts. Same thing. Let's do inch. But this time let's do a hex head screw. Here we are. And for the threads, let's select 3/8 16. So here we are, 3/8-16. And let's tell it again to have a length of 1 inch. And then it doesn't really matter which one we select because we don't really care about the alloy or any of the material properties. All we care about right now is getting the correct dimensions. And so let's just pick the first one. Once again, make sure it says 3D Step and go ahead and select Download. I'm going to go ahead and rotate this 90 degrees and drag it over just a little bit and hit OK. Couple more times. Insert McMaster-Carr part, screws and bolts, inch, and this time let's select a flathead screw. And let's do a slotted flathead screw. Let's tell it to be 1/4-28. And let's go ahead and select 82 degrees. That's just the standard. And let's give it a length of 1 inch. And you can see we really only have one option here. And so make sure 3D Step is selected and select Download. Let's rotate that into place, drag it off to the right here, and hit OK. One more. Insert McMaster part, screw and bolt. Make sure you have inch selected. And this time let's do a socket head screw. Tell it to be 3/8-16. And some of these measurements might be familiar, and hopefully it'll be obvious why in just a second. Give it a length of 2.5 inches, so 2.5, here it is, 2.5. And let's tell it to be partially threaded. Instead of the thread going all the way across, let's make it partially threaded. So you can select it here, or you can select it down here if you haven't figured that out yet. And let's find a minimum thread. So I'm going to go ahead and scroll down. I'm going to tell it to have a minimum thread length of, let's say, 1.25. And let's just select the first one and download it as a 3D Step. And this one should be considerably longer, but that's okay. And hit OK. And so what are we going to do with these? Well, now what I want to do is I want to actually insert this drill box as well. And it looks like I can't because I haven't saved this file. So what should we call this file? So I'm going to go to Save, and let's just call it bolts for drill box. And hit Save. And so now we should be able to drag this drill box in. I'm going to move it back just a little bit and drag it down, I guess, and hit OK. And so why do we have these? Well, ignore these first two holes because they were just sort of introducing you to how holes work. But I actually designed these 4 holes to fit these 4 bolts. And so let's go ahead and insert this one in first. So let's go to Assemble. Well, actually, let's ground this piece first. So let's ground our drill box. And you can't see ground, but if you right click on drill box, it is up above create drawing, I promise. And so I've grounded the drill box. We go to joint. I'm going to assemble the bottom of this to the bottom of my counterbore. And you should see that it fits in there perfectly. And hit OK. And if we grab our section view analysis, we'll go to inspect, sectional analysis, and drag it in all the way 1 inch. You'll see that it clears through this hole, and it looks like I got it a little high here, so I might need to go in and change that joint just a little bit, and I'll do that in a second. But you can see that it clears through the hole, and you only would have the threads at the bottom where you could put a nut right here to lock this or fasten this in place. Let's go ahead and change that joint real quick. I want it to go up just a little bit. How far up? Well, if I go up 0.1, that's obviously too much. What about 0.2 or 0.025? And it looks like that is just about perfect. There's a little bit of a clearance there, but that's okay. Hit OK. And again, you can see, what would be the point of this? Well, this would just drop through. It sits in our counterbore so that the head doesn't stick out, but the threads come out the bottom. Let's go ahead and turn off our sectional analysis. And let's go to the next one. And if it wasn't clear to you, the hole with the countersink has the bolt with the conical shape. And so let's go ahead and go to joint. I'm going to select this top circle and this top circle and hit OK. And again, if we were to go to our sectional analysis, you would see, well, it fits perfectly. And you might say, well, Mr. Anderson, it doesn't fit perfectly. Look, the threads are backwards. Well, that's probably because it was just inserted backwards. So we can just change that by changing our joint. And all we're going to do is rotate it 180 degrees. And you'll see now it fits perfectly, and hit OK. And so let's turn off this sectional analysis, and we can do the same thing with these last 2. So joint, let's see here. I want this bottom circle right here to join with, obviously since this is the wider bolt, it'll go in the wider hole. And I want you to look around and hover around until you find a side that lights up the center. And so you'll see this one doesn't light up the center, but this one, if I hover over it, it does at a certain point. And so just bring it around until you find that center that lights up, and then click. And bring it in. And hit OK. And then we can just real quick do the last one. Same thing. We'll go to joint. I'm going to go ahead and hit J on my keyboard. And same thing, get that bottom circle there to go on this circular face. And once again, you want to make sure you get the center selected. So dance around it until you find one that locks it onto the center, and click. And you'll bring it in and hit OK. And in the same way, we can check to see if our threads are matching, and you can see this one is not, and this one is not. It's because they both were off by 180 degrees, so we'll just change it to 180, and hit OK, and do the same thing on this joint, edit it, 180 degrees, and hit OK, and now they match. And so this is the idea. This is why you would use various holes. This is why you would use various sinks or bores for your holes. If we turn off our analysis, you'll see these 2 actually fit inside so that they aren't sticking out of the top, which might be important to the engineer. Whereas these ones just fit in, and then the tops just stick out of the top. And that might be okay. That might not be a problem. That might be exactly what the engineer wants. And so depending on what you're trying to do, you would create your holes in different ways for different bolts. Let's go ahead and save this and hit OK. And we are done with this video.